Hello everyone, my name is Varun Prasannan and I'll be narrating this PowerPoint presentation to you. The topic of our presentation is gesture recognition and conversion to speech for specially abled. This is a project by Dr. Sonali Patil, Chinmay Mukhedkar, Jaspreet Singh Pannu, Mukul Chaudhary and Varun Prasannan. Our paper ID is 142. Okay. Many researchers have worked tirelessly on developing gesture recognition techniques for the specially abled. They vary in many aspects, some of them being accuracy and efficiency. In this paper, we have focused on all the different gesture recognition methods and their respective efficiency and accuracies. All in all, a comparative analysis of methods are provided in this paper. There are many people in this world who suffer from hearing and speech impairment. For them to express their thoughts, it might be difficult at times. As engineers, we have this insane urge to find out how we can help others in their day to day life. We can solve this problem and bring many more accessibility features for the specially abled through the help of latest technologies. With the help of latest inventions in the field of human computer interaction, artificial intelligence, and machine learning, it is now possible to work on a system which can act as a mediator for the specially abled. The literature survey provides an analysis of existing methods and technologies. For gesture detection, data gloves are the most used technology worldwide, but the latest trends in machine learning have made it possible to achieve better accuracy in gesture recognition using cameras. A significant variation is seen in the efficiency, time, and accuracy between the different methodologies. The comparative analysis of the methodologies is given as follows. Hand gesture recognition using human-computer interaction. Indian Sign Language Converter using convolutional neural networks. In this paper, an Indian Sign Language Converter was developed using a convolutional neural network algorithm with the aim to classify the 26 letters of Indian Sign Language into their equivalent alphabet letters by capturing a real-time image of that sign and converting it into its text equivalent. First, a database was created in various backgrounds and various image preprocessing techniques were used to make the database ready for future extraction. After feature extraction, the images were fed into the CNN using the Python software. In a CNN, the network is formed with multiple nodes, also called as neurons. These nodes are connected to each other via links. Each link has its own weight, and as a whole, they produce the output. CNN likewise is a technique used for gesture recognition more accurately. CNN usually acknowledges all the neighborhood functions after which merges those neighborhood functions at a better level. This technique is used to gather the all-inclusive traits of the photo and its structure. Then the properties of the pics may be obtained. So in short, CNN has the upper hand in pixel price of the processing units. Hand gesture recognition algorithm based on double channel CNN. In the task of hand gesture recognition, the traditional method based on manual feature extraction is time consuming and the recognition rate is low. In order to improve the recognition rate, a novel recognition algorithm based on double channel convolutional network DCCNN is proposed. Firstly, the preprocessing, denoising, and edge detection of the original gesture images are performed to obtain the hand edge images. Secondly, the hand gesture images and the hand edge images are respectively selected as two input channels of the CNN. Each channel contains the same number of convolutional layers and the same parameters, but each has a separate weight. Finally, the feature fusion is performed at the full connection layer and the output result is classified by softmax classifier. Edge detection algorithm, an exceptionally speedy guided filter, is followed to reconstruct the unique gesture image. Therefore, as a way to optimize the training method of gesture recognition, the double channel convolutional neural network is proposed. Hand gesture recognition on Indian Sign Language using neural networks. The idea of this project is to design a system that can interpret the Indian Sign Language in the domain of numerals accurately so that the less fortunate people will be able to communicate with the outside world without need of an interpreter in public places like railway stations, banks, etc. The research presented here describes a system for automatic recognition of Indian Sign Language of numeric signs, which are in the form of isolated images, in which only a regular camera was used to acquire the signs. To use the project in real environment, first we created a numeric sign database containing 5,000 signs, 500 images per numerical sign. Direct pixel value and hierarchical centered techniques are used to extract desired features from sign images. After extracting features from images, neural network and K-9 classification techniques were used to classify the signs. A novel method for data glove-based dynamic gesture recognition. In this paper, an algorithm is proposed to obtain angle change data of finger joints by means of data glove, and then the process of dynamic gesture recognition is carried out by fitting the data to curves and calculating the Hausdorff distance between them. The experimental results show that the recognition rate of the method can reach 98% when the number of gesture categories are 10. The algorithm has low computational complexity with high efficiency, which can guarantee the correctness and robustness. The algorithm uses data gloves as its base. Initially, it uses the least square technique, and also the calculation of Hausdorff distance is done. Benefits of implementing this method are robustness, high accuracy, and reliability. The foremost downside of this method would be the speedy and potency of the system. Once the recognition result is applied, the HCI is increased within the virtual scene. Static hand gestures recognition based on CNN. In the proposed method, images are taken as input using a camera. The obtained images could have variable formats, scenarios, or backgrounds. So, to bring the uniformity in the image, they are sent for preprocessing. During the preprocessing, the images are passed through certain operations as follows. Color segmentation. In this, the algorithm identifies uniformity in colors in the image and identifies the cluster of pixels in the image. Next, morphological operations. In this, digital images are processed on the basis of their shapes. Two specific operations in this case are erosion and closing. Erosion removes pixels on the object boundaries. Closing first adds the pixel on object boundaries and then removes it simultaneously. Contour detection or contour generation. This is used to focus on the required area in the image. Polygon approximation. In this, the exact required area is detected and used. A logical AND operation is performed on the resultant preprocessed image so that it maintains the information accommodated on the fingers and surface of the hand. The images are then fed to the CNN to train the model, and results are stored and then analyzed using cross validation techniques. Indian Sign Language gesture recognition using image processing and deep learning. In this approach, they have used image processing and deep learning to identify the gestures. The proposed method focuses mainly on Indian Sign Language translation. Different static images are trained using CNN. The area of focus is on Indian Sign Language alphabets and numbers. A five-layer CNN model along with computer vision techniques is used in the method. The results showed the accuracy of 99.81%. With this, a method is proposed to identify the dynamic gestures too. For dynamic gestures, convolutional LSTM is used to train the video input of gestures. The model showed accurate real-time performance on prediction of ISL static gestures, leaving a scope for further research on the sentence formation through gestures. The model also showed competitive adaptability to American Sign Language (ASL) gestures when the ISL model's weights were transferred to ASL, and it resulted in giving 97.7% accuracy. Key findings. From all these comparative analysis, we have found that the images fed to the model can vary in types, sizes, resolutions, and backgrounds. We must look after the uniformity in images, which can be brought by resizing and reshaping them to maintain consistency. We have found that there is a huge difference in the images which are used for training and the images which are used in real life. The real-time images and a change in technologies may hamper the accuracy of the whole system. As there are many languages with different gestures, the models developed might generate incorrect output. Conclusion. The comparisons have led us to conclude that a lot of advancements are needed in the field of hand gesture recognition systems. More accurate and faster methods are needed to be developed for helping in communication using them. The papers analyzed and the techniques used in them have been shortlisted in our paper in such a way that one would get a perfect idea as to which algorithm would be the most efficient for them. Future scope. Voice assistants like Alexa, Siri are made for the general crowd without much disabilities. But in case of a disabled person, we don't have an affordable, efficient, and developed voice assistant available in the market. So there is a huge future scope for a voice assistant developed out of the ideas which is properly affordable, efficient, and safe for the specially abled people. Thank you.